In this presentation, we will learn how to multiply two polynomials with the help of a C program. So without any further delay, let's get started. Consider the following two polynomials. Let us suppose we are available with these two polynomials, that is 4x cubed plus 3x squared plus 1 and 5x cubed plus 7x plus 5. These are the two polynomials we are available with, and our target is to simply multiply these two polynomials. Each term of the polynomial 1 must be multiplied with each term of the polynomial 2. This is very important that each term of the first polynomial must be multiplied with every term of the second polynomial, and this is how it works. Multiplying each term means multiplying their coefficients and adding their exponents. This must be well noted, that multiplying each term means multiplying their coefficients and adding their exponents. For example, here you can see that this term must be multiplied with this term. This simply means that their coefficients must be multiplied and their exponents must be added. Similarly, this term must also be multiplied with this term, which simply means that coefficients must be multiplied and the exponents must be added. In this way, we will continue, right? So this is the resultant polynomial so obtained. Here you can see that 4 is multiplied by 5 and the exponents are added. Similarly, we will take these two terms, and here also 4 is multiplied by 7 and obviously the exponents are added. Here you can see the exponent is 1 and here it is 3. 3 plus 1. That's what I have written over here. After this, 4 is multiplied by 5 and here we have x to the power 0, right? So 4 is multiplied by 5 and here we will have x to the power 3 plus 0. Similarly, we will take these two terms and these two terms, and then we can take these two terms, and finally these two terms, right? So after multiplying all the coefficients and adding all the exponents, we will obtain this result. That is 20x to the power 6 plus 28x to the power 4 plus 20x to the power 3 plus 15x to the power 5 plus 21x to the power 3 plus 15x to the power 2 plus 5x to the power 3 plus 7x plus 5. This is the resultant polynomial obtained. Okay. Now we have to write the program which can multiply these two polynomials in the similar way and produce this result. For this purpose, of course, the first polynomial must be represented in a linked list, and we already know that how to represent a polynomial in the form of a linked list, right? And obviously the second polynomial must also be represented by a linked list. And what we will do, we will traverse these lists one by one, and then we will multiply each coefficient and we will add each exponent, right? Here you can see this linked list is representing the first polynomial and this linked list is representing the second polynomial. Currently you can see that head 1 pointer is pointing to the first node of this list and head 2 pointer is pointing to the first node of this particular list, right? We need two more pointers, ptr1 and ptr2, for traversal purpose. Obviously we cannot use these pointers head 1 and head 2 for the purpose of traversal. This is not a good idea, because if we traverse the lists with the help of these two pointers, then we will lose the reference to the first nodes, and this is not a good idea at all. We also need a nested loop, as each term of the first polynomial must be multiplied with every term of the second polynomial. As I have written over here that we need two pointers, ptr1 and ptr2, so let me just mention those pointers over here. You can clearly see this, that ptr1 is the pointer to the first node of the first list and ptr2 is the pointer to the first node of the second list, right? Now we need a nested loop, as each term of the first polynomial must be multiplied with every term of the second polynomial. So this is how a nested loop structure looks like, right? Obviously this is a nested loop structure. Here you can see that this is the outer loop and this is the inner loop. In this outer loop, I am checking this condition. If ptr1 is equal to null, then we will get outside of this loop. Otherwise, we will continue. Here also I am checking this condition. If ptr2 is equal to null, then we will get outside of this while loop. Otherwise, we will continue. Now, what shall we write in place of these three dots? Obviously, this is the main code, right? We must write something inside this while loop. Obviously, this must be replaced by this piece of code. Here you can see I have written res1 equal to ptr1 coefficient into ptr2 coefficient, res2 equal to ptr1 expo plus ptr2 expo, head 3 equal to insert head 3 comma res1 comma res2, ptr2 equals to ptr2 link. We must replace these three dots by this piece of code. Here I have selected two variables, res1 and res2. Res1 will hold the value of the multiplication of two coefficients. Res2 will hold the value of the addition of two exponents. and insert function is called for the purpose of creating the new node and also for the purpose of maintaining the descending order of the polynomial according to their exponents. This is also important. This insert function is same as the insert function which we have seen in the previous presentations. This insert function will not only insert the new node in the resultant linked list, but it will also make sure that the resultant linked list so obtained must be sorted in descending order, and that too according to their exponent part. Fine? And obviously ptr2 must be updated in this while loop every time. This is also required. Now this is the complete code. Here you can see first I have declared two variables, res1 and res2, and this is the pictorial representation of these two variables. After this I have declared this head3 pointer which is currently holding null. You can clearly see this, that head3 is holding null at this moment. Now let's execute these while loops one by one. First we are checking this condition, is ptr1 equal to null? You can clearly see this, that ptr1 is not null. So we can get inside this while loop. Now we will check, is ptr2 equal to null? Obviously ptr2 is not equal to null. So we'll get inside this while loop. Now here we will update res1 by ptr1 coefficient into ptr2 coefficient. What is ptr1 coefficient? ptr1 coef is nothing but 4 and ptr2 coef is 5. This particular portion of the node represents the coefficient part, right? So here 4 must be multiplied by 5 and we will store that result within this res1 variable. And obviously this will be 20 because 5 into 4 is 20. And what about this res2? res2 must be updated by ptr1 expo plus ptr2 expo, right? You can clearly see this. What is ptr1 expo? ptr1 expo is 3 and ptr2 expo is also 3. So what is 3 plus 3? 3 plus 3 is 6. So 6 will get stored over here. After this we will call insert function. Now this insert function is capable of inserting a new node in the resultant polynomial and it will also sort the linked list in descending order according to their exponent part. Here currently head3 is null. Obviously null will be passed to this insert function. But after the call of this insert function, when we will get back to this place, we will get this particular node. And obviously head3 is not null at this moment. Head3 is pointing to this particular node. And here you can see that the coefficient part is containing this value 20 and the exponent part is containing this value 6. After this, ptr2 must be updated so that it can point to this particular node, right? Now it's time to take these two nodes. We'll again check this condition. ptr2 is not null, so we'll get inside this while loop. And now we will update the res1 by the multiplication of these two coefficient parts, that is 4 into 7, which is 28. After this, the res2 must be updated by ptr1 expo plus ptr2 expo, which is nothing but 3 plus 1. So we will replace this by 4. After this, we will call insert function, and again with the help of insert function, we will create a new node which will contain these two values. Obviously in the coefficient part 28 must be there and the exponent part 4 must be there, right? So here the new node will be created, and obviously you can see that the exponent part is 4 and here it is 6. That is why the new node must be inserted after this node, right? And we don't have to worry about this. Insert function will take care of all these things, right? After this, ptr2 must be updated so that it can point to the last node of this list. And then we will again check, is ptr2 equal to null? We can clearly see this, that ptr2 is not null. So we'll get inside this while loop and then we will update the res1 and res2 by these values. That is 5 into 4. Here 20 will get placed and here 3 will get placed, right? After this, we'll call insert function once again, and this will insert the new node after this node because the exponent is 3 and here we have 4. New node must be inserted after this node, right? You can see that the descending order is maintained up to now. This is 6, this is 4 and this is 3. After this, ptr2 must be updated again. Here you can see after the updation, ptr2 must hold null. Now you can clearly see that ptr2 is null. This condition is not satisfied. So we'll get outside of this while loop. Isn't that so? But it is important that after this while loop, we must update ptr1 as well. Obviously, we must have to update ptr1 so that it can point to this node. That is why it is important to put this line, that is ptr1 equal to ptr1 link. This means that ptr1 is now updated and it will point to the next node of this list. Now, we will check this particular condition. You can clearly see this, that ptr1 is not null, right? So we'll get inside this while loop And now we will check, is ptr2 equal to null? Oh no, ptr2 is null. Okay, we haven't updated the ptr2. Actually, ptr2 should not be null, right? ptr2 must point to the first node of this list. For this, we know that head1 pointer is pointing to the first node of this list and head2 pointer is pointing to the first node of this particular list. So we must update ptr2 by head2, and that's what we will put over here. ptr2 equals to head2. After traversing the whole list, it is important to update ptr2 so that it can point to the first node, right? This is very important. That's why this line of code is required before this while loop. So after updating ptr2, this will now point to this particular node, right? And then after this, the same procedure will continue in this way. Now this is the complete code. Here I have put two lines, that is ptr1 equal to ptr1 link. This line is also important and this line is also important. ptr2 equals to head2. Without this line, this loop will continue to fail and the rest of the multiplications will not happen, right? That is why it is important to put this line. Now, obviously this is the resultant polynomial so obtained, but you can see there is a flaw over here. Obviously, in this resultant polynomial, the order is not maintained. Here you can see there is no order among these terms, right? But the resultant polynomial that we will obtain after the completion of the code must look like this. Here you can see that we will get this polynomial after executing the code because of insert function. There is no doubt about this. Here you can see the terms are arranged according to their exponents, and that too in descending order. Now let me just show the complete code in code blocks. You can see that struct node must be declared, and here insert function is already defined. We are already aware about this insert function. There is no need to explain this right now. And you can see this is the create function. This will help us in creating the polynomials. And this is the print function, right? After this, we have this polymult function. Here you can see that I have declared two pointers ptr1 and ptr2, and they must be initialized by head1 and head2. After this, you can see head3 pointer is also declared. And here first I am checking this condition, if head1 is equal to null or head2 is equal to null. If first or second polynomial is null, then simply print 0 polynomial. That's what I want to print and return. Otherwise, just multiply the two polynomials. That is what I am doing over here, right? And obviously, everything starts from the main function. First, the two polynomials are created, and then after this, polymult function is called for the purpose of multiplication of two polynomials, right? Let me just execute this code. It is asking us to enter the first polynomial. Let's say I want 3 terms in the first polynomial. Let's say the coefficient for the first term is 4 and the exponent is 3. Coefficient for term 2, let's say it is 6 and exponent is also 6. Let's say the coefficient for term 3 is 8 and the exponent is 1. Now let's say I want to enter the second polynomial, and let's say the number of terms that I want to add in the second polynomial is, let's say 4. Let's enter the coefficient for term 1, let's say it is 7 and the exponent is 3, 3, 2, 2, 1, 1, 0. This is the resultant polynomial so obtained. Here it is 42x to the power 9, and this term is obtained by multiplying these two terms, right? 7 6 is 42 and 6 plus 3 is 9, right? And you can check this, that this is the resultant polynomial, right? Okay friends, this is it for now. Thank you for watching this presentation.